So, hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 97 and in this video we are talking about function overloading. First of all, I continue with the example from the last video and you can see I added here two more functions, or I think one more function at least. So, and here are the forward declarations. So we already see I have 3 times add function and this here got a const in it, and then I have here a referenced, and here are the places where I use it. Here are the function definitions, and you can see the first one is just a normal function with a return type int and normal int variables. The second function is again a function with a return type int, but we can see we have here a const, and then we have a reference, a const reference, and the other are normal references. And the last one you can see here we have all const and all const references. So, and I want to talk about overloading here. What means overloading? Actually, when you look this function forward declarations, there is something suspicious, right? The first thing is I use 3 times add. And then we can ask, what's the problem? The problem is when we call add, what we do, how the compiler should know which add he should use. And the answer is the compiler will first look up the name. For example, if we call here, this is my int main, and here I'm calling the first add at this place, and you can see here the compiler look first up this name, and then it jumps and finds, oh, I found in this file, for example, 3 adds, and then the compiler say, okay, now I'm looking up all the arguments. So that means I have here used 2 arguments for the call, and then the compiler will check all the arguments, all the parameters of these definitions which he found. So this got 2 parameters and this got 2 arguments that fits. That means the compiler will jump here and use this one. On the other side, for example, I called also here an add with 4 arguments. For example, that's a little bit tricky here. I called here x, y, z, and the last argument is x plus 2. Because that's also possible to call. I just used the x variable and added 2 for it. So what does here the compiler do? The same like before. The compiler will first search for add, and then this compiler says, I found add, but I found it 3 times. So I have to choose one of them. So I have to check all the first, he says how many arguments are used. Okay, I found 1, 2, 3, 4 arguments, which means I need a definition with 4 parameters. So 4 parameters. The first one has only 2 parameters. No. The second one has only 3 parameters. No. And the last one has here 4 parameters, and these parameters are must match to. What I mean with must match to, for example, this x is a int x parameter, right? And this const int 8 reference is also int parameter, even if it's const and is a reference, because these are additional restrictions. So the compiler will say, okay, I found here an int parameter. This is matching with this x. And the same goes with y. The y is an int. Yes, I found here again an int parameter, which is matching. Const and reference are additional restrictions or extensions. Depends on that, how you see it. And the same goes for set. And for the last one here, the compiler says, okay, this is an expression. Expression means you have he is first executing this one here, which means he say, okay, x plus 2 is 6 here, but it will the return type of this expression is still a int, so the compiler says, okay, I found this well, here is a int. And so the compiler can determine which add he is using. So it's behind the scene, it's a little bit more complicated, but for us as a programmer, we say, okay, we have just watched this arguments plus this parameters, then we know what the compiler is choosing. Very easy for us. So when we have here two arguments, but these arguments must match, right? We have to check this x is an int, yes, y is an int. If this match, then it will choose the right function. And this, what I did here using the three times the same name for this function, is called function overloading. Overloading means you have one name, three functions with the same function, with the same function name, and the compiler must then check additional features to determine which function to choose. So let's create one more overloaded function, but this time, careful what I'm going to do. I call this one double, again add, and let's make this one very short. So let's make here a int a, int b, and let's go here, return, let's create here one more thing, which is int a is equal to a plus b. No, let's make it other way. Let's write here double, oops, not bubble, double, and this one is normally not possible, but it will convert it behind the scene to a double. So let's say here comment converted behind the scene. You have to read that in the documentations or in online books and C++ books, but this is not so important here. Important is here that I return now this double, because oops, not double, I return this a, of course, and now I need this forward declaration. All right, let's make this forward declaration here, and let's call this again. So we have here add. It is still complain candidate overload function by return type alone. Yes, and here is the first problem. So I wanted here again overload. You can see in the tooltip perhaps it says cannot overload function, because I tried to overload a function. Overload means, like I said before, I use the same name, and here I try to overload and it says it can't, because here I use the same name and here I use the same parameters, which means two parameters, and these are the same, and the compiler checks all time first the name and then the parameters, but the compiler says in this case, wait a minute, this got also an int, this got also an int, and has the same function name like this one, which means now I can't distinguish. This is not allowed. Normally I want to show you that this one is allowed. For example, the return type is allowed, so the compiler will not complain about the return type, because the compiler don't care about the return type, but the compiler cares about the name and the parameters. And let's change this here to a double. Let's make this a double as well. Let's make this, yes, one double here, and let's change this one here down to a double. Okay, and now not bubble, oh man, all right, and now you can see there is no more complaint. Now the compiler says, okay, I check again the name, I found it 4 times here, and now I will check the caller's parameters. This got here 2 parameters, this got also 2 parameters, but these parameters are still not the same. This one is a double a int b, and this one is a int a int b, which means if you call this one here, the compiler will go here to x, it checks which type is that, int. Okay, I found one int here, and then it checks the second. It say y is also int. Okay, I found it here. And he checks this one actually also behind the scene, but he say no, this is a double, so this I can't use this one. So that's so more or less function overloading. Important is this return type doesn't matter. Only on function overloading, important is this function name and then the parameters here which you are going to use, and that must match with the caller. So for example, if I want to use now this double here, let's call this one here. Let's make here one more call, and this one is this R value, which means I can just write anything here for a moment and add, for example, I need here a new variable, and no, I call this double, and I call this here 0.03, anything like that. And oh, I need a variable name. Let's call it w, and now I can call here at u, comma, and for example x. So, and now you can see I have called this one, and now this works. And of course I can print this one as well out. Why not? Let's do this. And we print this one out. Instead of k, I use here u. And start. And we have an error. So let's see what's the problem. It says redefinition of a. Okay, this one is not allowed. Double. Let's change this one. Redefinition of double. Ah, yes, of course. Here, I'm stupid. I should not. Here is it a declaration, a definition, and here I did the same. Of course, I should use here another variable name, and that's again a very good sign that short variable names are crap. We will talk about this in a moment, and now start it. And you see it is working, and all the numbers will match. So the important thing here that you have to remember, function overloading means you use the same function name, but the compiler will then check if he finds other ones, and then he will check the parameters. If the arguments are the caller, so the caller is here. If this caller arguments, which is x, it's this one int, is matching with the parameters, which is, for example, in this case here, this one. So it checks this one with this one. And if it matches, and not only one, it must check all the parameters here, then the compiler will say, yes, I have found one, it's okay, you can go on. So, and we have to train this overloading, but one more sentence. Why the hell they are using function overloading? Because this add and add and add, it is very bad actually, because a function name or a variable name or anything must very descriptive, and this one is actually not descriptive at all. So why the hell they are doing this one? The reason for that is there are cases where you are just adding with one more parameter. For example, like this, it starts adding, it is all time add. It says now I have add 2 values, now I add 3 values, and now I add 4 values. Call them all add, and perhaps they are in a special place where you know exactly what this adds all, right? And instead of writing then all time a new name, because they say the programmer must not remember different kind of names, because if I write now, I could write for all names add 2 parameters. Then I could write here add 3 parameters and add 4 parameters. Instead meters, yeah, something like that. Instead of remembering add all these different function names, they say you just need to remember one function name, and then you have only checked the parameters what you want used later. And that comes very handy later. For example, if you have not so easy functions like this one, for example, you see I use sometimes very, very long function names, and then to find all time different function names with for functions who are doing essentially the same thing, they say just write one function name, and if they are doing a similar thing, just change the parameter. So that's one reason why they do this one. Because this is then very handy. On the other side, you need to know that this other kinds of parameter exist. This is on the other side a little bit bad, because if you don't know it, then you say how I can find it. But most time they pop up in calls. For example, here you can see it. If I call it add, and then you will see that there are probably, here is a tooltip, and it says here 1 of 4. And this 1 of 4 means the compiler found here 4 options. So when I click here, this is the second one. And it's a little bit hard to see here, this little tooltip here. I click on it and I have these 4 options, and these 4 options are actually this one here. So this is one nice thing, you can use it. So the overloads are shown here too sometimes. And this one, this little tooltip here, I can't zoom in right now, too bad, is very important later, because you will see in programming they have lots of overloaded functions, but not only functions, also operators and many other things. But we are learned here the functions. And with that said, before I stop, I want to mention here one more thing. And what is this one more thing? Actually, 2 more things. The first thing is, no, let's mention only one more thing. Here I made a big mistake. What was it? I used the demonstration. I continued with the demonstration with this function parameters and so on. And what is the big mistake? This demonstration used very bad namings. They used here A, B, X, Y, Z. This is similar to math, right? In math, they use also this little namings, and that is a programmer have never do this as a programmer, never. And why you should not do it? Try to read now this code here. Just try to read, let's say, without thinking too much. And the problem is, you must think here and search, what the hell is this Y? What is this doing? Why is the Y here used? What is this add? What is this adding? And then why the hell they have X and Z? The only thing is, probably you know now all this X, Y, and Z, because I showed you here that these are variables and so on, and we are using this now. But in general, when there is another programmer and comes here and say, holy hell, what is that? And he starts to encrypt all these signs. This is very bad. So as a programmer, never do this. As a mathematician or for a demonstration, that's probably normal for them. But for programmers, no go, no go. Never write a code like this. But of course, on the web, you will see a lot of this kind of examples, because it's shorter and they want just demonstrate it. But actually, this is not this is, let's say, not very good programming. This is not, at least you can't use it really. You will waste a lot of time just to encrypt this crap. So that's why I say crap, because you think about it. What is A? And a programmer wants to read one name. He wants to know instantly, without reading it again, what this variable is doing or what it's used for. And then he won't concentrate on his task. That is very, very important for a programmer. So keep that in mind. In web, you will see many are showing stuff like this one, and I did it here too, but that was only so that I can complain here more about myself, and never do this again. All right, so we have here no clue what this all are really doing. This C, D, yes, nothing, I have no clue. This I, what is that? I have no clue. Thanks for crap programming. So with that said, I hope I don't complain about, but I complained about myself because I showed you this one, right? I programmed here and used this example, but I will never do this again, probably. Only keep in mind, for demonstration purposes, they do this a lot, but this is not programming, right? Think about this. This is not programming. This comes from math and for demonstration purposes, but has nothing to do with programming, because you will have problems if you do something like that in programming. There's only one case where I know this is used in programming. I mean general, all these little words. And this is if you want to try to encrypt your programming. So let's say it, if you try to make it not readable. For example, for reverse engineering, there are many people who try and make their program so unreadable as possible. They would even use worse signs than this one, but this is a special case. In general, don't make it. So with that said, I stop here. If you have any questions or any complaints, write it in the comments, and bye and good luck.